Hey everyone, welcome back to Math with Sammy. Today we're diving into graphing linear and logarithmic equations, two fundamental math concepts that show up everywhere, from algebra to real world applications. If you ever struggle with these topics, don't worry, I'll break everything down step by step. So by the end of this video, you'll feel confident in graphing both types of equations. Let's get started. So we will start with graphing an exponential function, which is y equals 2 to the power of x plus 3 minus 1. So we could graph this in so many different ways, but I think the best way is to use transformations. The parent graph, y equals 2 to the power of x, looks like this. These are important points on the graph right here. So this one right here at 0 and 1, also at 1 and 2, 2 and 4. And then how we got these points, basically, I'm just subbing in the x values into the equation here. To graph this, I'm going to find the x-intercept first, and then the y-intercept, and then the equation with asymptotes. And after we graph it, we're going to tell what the domain and range is. Yeah. So here, the x-intercept, all you need to do is make y 0. So I'm just going to do this on the side here. So if you make y 0 equals 2 to the power of x plus 3 minus 1, I'm going to move the negative 1 to this side. So it becomes positive 1 equals 2 to the power of x plus 3. Now I know 2 to the 0 gives you 1, so I'm just going to change that to 2 to the power of 0 equals 2 to the x plus 3. Now we could cancel the bases now, and we have 0 equals x minus x plus 3, and therefore x equals negative 3. And I'm going to use a different color for the graph. It's going to be at negative 3, so it's right here. Yeah. Now let's calculate the y-intercept. And the y-intercept, we make x0 in the formula for the equation and solve for it. So the y-intercept will be y equals 2 to the power of 0 plus 3 minus 1. 2 to the power of 0 plus 3, that's 2 to the power of 3, which is 8, minus 1 is 7. So the y-intercept is 7, and I'm just going to use the different colors. So the y-intercept is 7. Yeah. Now, the equation of the asymptote is the x-axis here. So the only thing that's going to affect the asymptote is any vertical shift. And as we see, the vertical shift for this graph is going down 1. So that means this asymptote is going to go down 1. So I'm just going to draw an asymptote. Yeah. Also, now I have the x-intercept, the y-intercept. What I'm going to do, the transformations that's happening to this graph compared to y equals 2 to the power of x, the graph is moving 3 to the left, the x plus 3, and down 1 because it's minus 1. So let's take some of this point and move them to the left 3, 1, 2, 3, down 1. So that's just the x-intercept. Now let's take this, move it 1, 2, 3 to the left and 1 down. Let's take this, move it 1, 2, 3 to the left and 1 down. And then take this 1, 1, 2, 3 and move it. So I just noticed that basically when I was graphing this, I get this point in the wrong place right here. So when x is 3, 2 to the power of 3 is 8, and I put it on 9 right here, so we're going to fix that a little bit. Let me just go ahead and fix that. Point supposed to be here, I'm not there. So let me erase this graph. The parent graph should have been looking like this. That's how y equals 2 to the power of xs. So now, again, we're just going to go back to the shifts. So it's shifting 3 to the left and 1 down. And basically, that's the y-intercept. We already calculated that. Okay. So that now we know our x-intercept is -3. Y-intercept is at 7. And the equation of the asymptote. Now, the asymptote is this dotted line right here. And this dotted line is y equals -1. The domain, let's graph this. So it's going to get very close to the asymptote, never touch it. And we have this. And this is how y equals 2 to the power of x plus 3 minus 1 looks like. Yeah. So that domain, the domain for any exponential function is x ER. It means x is a member of all real numbers that covers all the x values from -infinity to infinity. But the range, if you look under the asymptote, the graph here, the blue graph, is not represented. So it starts from -1 on, and -1 is not included because you get close to it, but you never touch it. So the range would be y is greater than -1. And that's how you graph this exponential function. Now, if you notice, I put that logarithmic equation right here because that's what we're going to graph next. So let me just get rid of everything that we graphed here, or all the work that we've done. I'm going to leave that equation there at the end. I'm going to show you something that I want you to know. Y equals log base 2 x plus 1 minus 3. So I'm going to graph the parent graph first. And the parent graph for the log looks like this. You go through 1 and 2 and 1, 4 and 2, and 8 and 3. And the y-axis is the asymptote. So this would look like this. My hand is usually shaking, so I'm very impressed with myself today because I could graph this without going all over the place. So this graph here is the y equals log base 2 x. Okay. Now, a lot of you, like for me, I could just sub in points. Like if I sub in 1 for x, then I go 2 to the power of what gives me 1, that's going to be 0. And then when x is 2, then I go 2 to the power of what gives me 2, that's 1. So that's why we get 2 and 1. And when x is 4, so if we make x is 4, so I'm saying 2 to the power of y equals 4, so y must be 2. And then if x is 8, then I go 2 to the power of 3 equals 8, and that's why you have 8 and 3. I chose those points because these are the points that would work without having to use the calculator. Otherwise, you have to use the calculator. Okay. So these are the important points on the parent log graph, which is y equals log base 2x. All right. And after that, all I need to do here, again, let's write our things down that we're supposed to find. So we want to find the x-intercept, y-intercept, equation of the asymptote, okay, and then we're going to tell the domain and range. Let me just get rid of this because we already wrote that now. Okay, so some of you have to remember your log rules and how to manipulate logs and stuff like that. So now let me find the x-intercept first. To find the x-intercept, I make y 0. So I'm going to take that right here, and I'm going to say, okay, if I want to find the x-intercept, I make y 0 equals log base 2 x plus 1 minus 3. Moving the negative 3 to the other side, so I get 3 equals log base 2 x plus 1. And then I want to change this to exponential form, so I go 2 to the power of 3 gives me x plus 1, which is 2 to the power of 3 is 8, and then move the 1 to the other side, becomes minus 1 x equals 7. That's the x-intercept. So I'm going to plug in my x-intercept, which is right here. How about the y-intercept? The y-intercept, all we need to do is just make x 0. So y equals log base 2, 0 plus 1 minus 3, which is y equals log base 2, 1 minus 3. Log base 2, 1 is 0, because 2 raised to the 0 gives you 1. So just know if you log in, doesn't matter what the base is. If you log in 1, it's always 0. So 0 minus 3, and therefore the y-intercept will be minus 3. So the y-intercept is going to be right here at minus 3. Okay. Now, let's use transformations here. So if we're doing transformations, I know this moved 1 to the left because of the x plus 1 here, and then 3 down because of that minus 3. So we know in the log graph, the y-axis is the vertical asymptote. So the vertical asymptote could only be affected by horizontal shift. So that means this asymptote moved 1 to the left. So your asymptote is going to be right here. So I'm just going to draw your asymptote first. Yeah, so I'm going to take some of these points right here. So let's start at this. Move it 1 to the left and 1, 2, 3 down. So that's just the x-intercept. This became the x-intercept. Let's take this, move it 1 to the left, 1, 2, 3 down. And then let's take this, move it 1 to the left and 1, 2, 3 down. And then take this, move it 1 to the left and 1, 2, 3 down, which is my y-intercept. Again, we're just going to connect these points. We're going to get very close to the asymptote. And therefore, this is the equation of y equals log base 2 x plus 1 minus 3. Okay. Now, let's write the x-intercept here. The x-intercept is 7. The y-intercept is negative 3. The equation of the asymptotes is this vertical line, and it's x equals negative 1. The domain here, if you look at this green, bright green graph, you know it doesn't touch the negative 1, and anything after the negative 1 on the x-axis going to the right to positive infinity, that's the domain. So therefore, the domain is x is greater than, but not equal to, negative 1. And the range, this is keeps on going forever down and keeps on going, even though slow, but it will go up forever. So the range will be y is all the real numbers. All right. Now, I said at the beginning, I chose these two graphs. So basically, we chose these two graphs right here. And I want you to notice something, okay? These two graphs, they are the inverse of one another. And how we find out? Let's look at some of the points. Look at this point at negative 3 and 0. So if we have a point at negative 3 and 0, the inverse of it will be 0 and negative 3. So do we have a point at 0 and negative 3? Yes, indeed. There's 0 and -3. We have a point at -2 and 1. What's the inverse of that point? It's 1 and -2. Inverse means you're inversing the 2 points. Do we have a point at 1 and -2 here? Yes, we do. And then here we have -1 and 3. Which gives me, for the inverse, that's going to be 3 and -1. Okay, and we have 3 and -1. And therefore, these two graphs are the inverse of one another. And you know the inverses are a mirror image of each other in the line or the diagonal line y equals x, which is, I'm going to draw it out for you. And as you see, the blue graph, the exponential graph, and the green graph, which is the logarithmic graph, they reflect in the line y equals x, which proves that both are the inverse of one another. Great job making it through. Now you know how to graph both exponential and logarithmic equations with ease. If this video helped you, be sure to hit that like button and subscribe for more math content. And if you have any questions, drop them in the comments. I'll be happy to help. Thanks for watching, and I'll see you in the next video.